So the chapter is particle physics. So first lesson is we have to discuss about the atoms. The central part of the atom is nucleus, which is containing proton and neutron. And outside, electrons are revolving. So there are the two parts of the atom, one the inner and the other one is the outer part. Now the size of the nucleus, this diameter. So diameter of the nucleus is equal to either 10 power minus 14 meter or 10 power minus 15 meter. This is the size of the nucleus or diameter of the nucleus. And then the size of the whole atom, mean this diameter of the whole atom is approximately 10 power minus 9 meter or 10 power minus 10 meter. Now, whole mass of the atom is due to its mass of nucleus, mean due to the mass of the nucleus. So nucleus is the central dense part, whole mass is due to the nucleus. The reason behind the mass of the electron very small, 9.11, 10 power minus 31 kilogram is too small as compared to mass of particles inside the nucleus. Like mass of the proton, mass of the neutron is 1.66, 10 power minus 27 kilogram. So the mass of the nucleus is too large. So the whole mass of the atom is approximately equal to the mass of the nucleus. Now each atom is represented by its symbol here, the atomic number, and here the mass number. This Z is representing the number of electrons or number of protons in a neutral atom. But if this is representing the nucleus only, then the Z is representing the number of protons only. And A is called mass of atom, atomic mass. And this A is actually the sum of protons plus neutrons in the nucleus. Now, the mass of the proton exactly equal to the mass of neutron, which is represented by U, and the U value is 1.66 into 10 power minus 27 kilogram. So when this mass number is multiplied with U, then this is the mass of the atom, which is also the mass of the nucleus. So the mass of the atom, mass of the nucleus is equal to AU, where A is the atomic number, the mass number, and U is the mass of proton or neutron. So A is actually the number of the proton plus neutron. When it is multiplied with U, it gives the total mass of the nucleus, which is also the mass of the atom. Now, the density is mass per unit volume. Now, nucleus is very, very small. Atom is very, very small. Both are considered sphere, perfect sphere. The volume of the sphere is 4 by 3 pi r cube, which can be written as 4 by 3 pi. Radius can be written as diameter by 2 and cube. So it can be written as 4 by 3 pi diameter cube over 2 cube 8, 4 ones are 4 twos are. So the volume can be written as pi divided by 6 diameter cube. But remember, for atoms, nuclei, molecules, we can ignore this portion pi by 6, but it's not necessary. We can use pi by 6 diameter cube, but we can ignore this for atom volume, for the nucleus volume, for the molecule volume. We can write volume is equal to diameter cube. Only for the atom, only for the nucleus, only for the molecule. And then if the volume of one atom is calculated, then the cube root of this is equal to diameter. So this diameter cube is equal to volume power 1 by 3. This diameter, not cube, sorry. So this is also called the spacing between two atoms or two molecules. Reason behind. Look, if this is the first atom, this is another atom. In physics, all distances are measured from center. This is a center, this is a center. This distance is radius, this is radius. Radius plus radius, it becomes diameter. So this diameter d is also known as molecular spacing or atomic spacing. Okay, so the diameter is also the spacing between the two atoms or spacing between the two molecules. Now come to the density. Density is equal to mass over volume. So the mass is represented by AU and the volume represented by diameter cube. You can write 4 by 3 pi r cube, pi by 6 diameter cube, or this is the shortcut, diameter cube. Now, we have to compare the density of the nucleus and the density of the atom. So the density of the nucleus divided by density of the atom ratio is equal to mass over volume of the nucleus divided by mass over volume of the atom. Now, the mass of the nucleus is AU and the volume is diameter cube of the nucleus divided by AU mass of the atom divided by diameter of the atom cube. Now it can be written as A times U divided by diameter of the nucleus, suppose 10 power minus 14 cube, multiply by this whole. So it becomes diameter cube of the atom, which is 10 power minus 9 whole power 3 divided by AU, because this division is multiplied, so it's reciprocal. Now, AU cancel with AU, hence the density of the nucleus and the density of the atom ratio is 10 power minus 9 over 10 power minus 14 power 3. So we can write 10 power minus 9 plus 14 whole power 3. So 14 minus 9 is 5. So 10 power 5 whole power 3. So this ratio is 10 power 15. It means the density of the nucleus is 10 power 15 times the density of the atom. This is the ratio between nucleus density and the atom density. So the density of the nucleus is too large as compared to the density of this atom. Now, it shows that most part of the atom, most volume of the atom is empty. Only central part, which is called nucleus, is dense due to this ratio. Now, the central part, dense, which is nucleus, it contains famous particles, protons and neutrons. So all particles inside the nucleus are called hadrons. They are hadrons, and they are not fundamental particles because they are made up of further small particles which are called quarks. So hadrons are the particles which are inside the nucleus. They are not fundamental particles because they are further divided into small particles. They are composed of the small particles. They are called the quarks. So quarks are used to form the protons and neutrons, mean the proton and neutrons are made up of quarks. Now there are 6 types, 6 flavors of the quarks. Number 1 is up, number 2 is down, number 3 is top, number 4 is bottom, number 5 is charm, and number 6 is strange. So we have to discuss only these two, up and down. So this up quark has plus 2 by 3 elementary charge, down minus 1 by 3 elementary charge. Now each quark has its anti-quark, opposite, having the same mass but opposite charge. So if up is represented by U, then the anti-up represented by U dash, and its charge will be minus 2 by 3 elementary. Similarly, this down is represented by small d, and the anti of the down quark will be plus 1 by 3 elementary charge. So each quark has its anti-quark. If the hadron is made up of only quarks, like proton is the combination of 2 up, 1 down quark. Neutron has the combination of 1 up, 2 down quark. So they are called hadrons. But if one of the anti-quark is involved in the composition of the hadron, then it is also named as baryon. So we have to discuss here the only hadrons, mean up quark, down quark for proton and neutron. But do remember, if any anti-quark is involved in the composition of the particle, then it is also known as baryon. Look, proton has a combination of 2 up, 1 down. So 2 up, 1 down. It means 2 times plus 2 by 3 elementary plus 1 minus 3, 1 by 3 elementary. It becomes 4 by 3 elementary minus 1 by 3 elementary, 3 LCM, 4E minus 3E, sorry, 1E. So it becomes 3E by 3 cancelled. That's why the proton has plus 1 elementary charge. So due to this combination. And similarly, neutron has 1 up quark and 2 down quark. So 1 plus 2 by 3 elementary plus 2 minus 1 by 3 elementary. So this is 2 by 3 elementary, 2 by 3 elementary cancelled. So it has no charge. So neutron is neutral. It has no charge. Now, inside the nucleus, there are charged particles, there are neutral particles, right? So due to their masses, they have gravitational forces. And due to their charges, they have electric forces. And all forces are vector. So there will be a single resultant force due to this gravitational effect. Electric effect mean the combination of all, vector sum of all gravitational forces, electric forces, is a single resultant force, which is known as strong force, not the forces. This is the resultant, single one. So all particles inside the nucleus, they are under the influence of a single force, resultant force, which is called the strong force. It is the vector sum of the gravitational forces, electric forces, and this strong force has effect only inside the nucleus, so it has range equal to diameter of nucleus. And the diameter of the nucleus is 10 power minus 14, 10 power minus 15. So if the question is, what is the range of the strong force? We have to quote either 10 power minus 14 or 10 power minus 15. So this is a strong force which is affecting all hadrons, mean which is affected only inside the nucleus.